Hi, everyone. So before we start with the notes, I'd like to start off with some fun and games. I have to admit, I loved being sick in fourth grade. Not so much now, but I loved being sick in fourth grade because then I could stay home and watch my favorite game shows, including this one that really got me into math, Card Sharks. So this first channel is our classic game show channel, an informal channel, I guess. You can subscribe if you wish. I'll send the links by email. And the second channel over here by Blackwood Company, again, you can subscribe to this one. But these are two clips from Card Sharks, starting with an opening ditty. Actually, these poems change from episode to episode.
The deuce is nice. The ace is great. But it's the middle cards that will decide your fate on Card Sharks. And here's the host of Card Sharks, Jim Kelly.
I thank you very much.
All right. Now, we're going to meet Norma and try to figure out how Norma's bank account is changing over the course of this final round.
Back with our champion, Norma. We want to give you the opportunity to play the money cards. They've been dealt out in front of the audience, and here we go. Choice of two base cards on the bottom level, and of course, you can change them as you move up. With $200, Norma, you'll start with a 10.
Change it. Bad card for me.
Change to that 10. Let's see if we can make a good change. Change it to ace again.
Okay, let's go for a whole shooting match for less, for lower. $200
Let's
for
not
lower.
have another double ace.
No.
$200 lower than an ace. It is a 4.
Okay.
Doubling it to 4.
Shoot the works for higher.
Again, the whole
Shoot it
thing.
all.
$400 higher. Yes, with a king.
Okay. Shoot it all. Higher. Okay, lower. Excuse me. Thank you.
$800 lower than a king. Yes, and very much lower. You cleared the board on the bottom level. $200 more dollars.
Okay, let's keep the 3. Let's go for everything. Let's go for higher.
$1,800.
Yes, let's go for it.
Higher than a 3. Yes, and a jack. $3,600 and a jack.
Okay. Gee, let's shoot it all. I came with nothing. I'll leave with nothing. An ace, a king, a jack. Let's go for lower and let's shoot it all.
Oh my, you are a gambler.
Let's go. Come on.
$3,600 lower than a jack. It is with a deuce. $7,200 and a deuce.
Shall we go for all of it? Yes. All of it and higher.
$7,200 higher. Yes, with a queen. Norma, you are on the brink. I don't know. Your decision. Do you want that queen?
Yes.
$7,200 you must bet. You have 14-4.
Shoot the match. The whole works.
Nothing or $28,800.
Lower.
Lower. Yes! She broke the bank. Everything. Oh, wow. Oh, yeah. That's super. Oh, we're so happy for you. That's the first time it's been done. That takes a lot of guts. Good card. Oh, my.
I'm going to call Japan tonight.
You're going to call Japan?
Calling Japan, even with the commercial cost. I've got
That
to
is
call.
wonderful. And of course, with the money in the game, Norma, you just finished up in one game $29,000.
All right. Well, good for Norma. So that was an example of exponential growth, and that's going to be a key theme of Chapter 3. All right. So before we formally introduce the notes, let's have some more fun with exponential growth. Okay, so Card Sharks. Well, here's the deal. Cost of living is exponential, right? So here is a U.S. inflation calculator. So this episode was taped in 1978. By the way, I should credit NBC for Card Sharks. Okay, so this episode was 1978, and let's say that Norma spends it all all $28,800 on something. All right. Then the year 2020, how much would it cost? Let's hit calculate. It would cost over $114,000. So something that was worth $29,000 back in 1978, the equivalent of that would be over $114,000 in 2020. I'm basically saying that cost of living is exponential. All right. So on Mathematica, I did some basic calculations. An estimate for what $28,800 from 1978 would be today, dollars, American dollars. All right. Now, inflation has not been constant, so it's not strictly exponential. Cost of living has not grown in a strictly exponential sense. But average inflation has been 3%. So, as a rough estimate, let's assume that inflation has stayed constant at 3% per year. It's a very simplifying assumption, but it will help us with modeling and with estimates. All right. Well, we get something close to the inflation calculator result. The inflation calculator said over $114,000. Well, okay, it's been 42 years since 1978, and this basic calculation says about $111,000. So remember, $28,800, that was the value in 1978, the cost of something, I should say, in 1978. Inflation, let's assume, is 3.27% annually per year. We'll talk about that. So this base year is 1 plus 3.27%, or 1.0327 raised to the 42nd, because the inflation rate we're assuming is 3.27% each year. So in terms of the cost of living deal, right, that's going to be exponential growth over those 42 years. So something that would have cost us $28,800 in 1978, assuming that the overall basic value stays the same. In pure money, it would cost us over $111,000 or over $114,000 today. Okay, now what if Norma had invested the $28,800 in the stock market before this latest crisis hit? Well, at least before this latest crisis, the stock market has grown on average about 8% per year. Of course, it's had its ups and downs. We've seen that. But as a simplifying assumption, let's assume that the stock market has grown 8% per year, just simplistically. Well, we start with $28,800. Let's say she invests it, 8% growth. 1 plus 8% is 1.08. See, we need the 1 there, because if we didn't have the 1, then she wouldn't be growing. She'd be shrinking. she basically would lose money with each new year. Okay, so she's growing. We have 1 plus 8%, 1.08. Every time another year elapses, we multiply by 1.08. She's growing, growing, growing exponentially. Okay, lo and behold, at least before this latest crisis, she'd have over $729,000. All right. If you want to, and now here, let's model what she did in the actual game show. All right. So she started off with $200, and she basically doubled down. She was getting twice as much money with each new turn of the cards. So every time there was a turn of the cards, X increased by 1, and that leads to a doubling of her current bank account on Card Sharks. Now, I do realize that she got a bump of $200 in the middle. Let's ignore that for now, although that would be beneficial to us if we cared about our money. Okay, well, this is the curve that we get. Y equals 200 times 2 to the x. You can barely see the 200 down there, right? So she starts off with $200. This is a smooth curve. Technically, it's really dots or points. It's really a geometric sequence, which we'll talk about in Chapter 9. But let's smooth it out, and let's say it's this exponential curve. Y equals 200 times 2 to the x. It's a J curve, a J graph. Science professors, chemists, physicists love to refer to these things as J curves or J graphs. And as you can see, By the time it came to the seventh turn of the cards, she turned over 7 cards, remember, okay? This thing predicts that she would be making over $25,000. Again, remember, she got a $200 bump in the middle, so she actually made a bit more than $25,000. But a pretty good job of modeling, and it's this J curve, very rapid growth. When we hear of exponential growth, we think very rapid growth. And ladies and gentlemen, yeah, it's been in the news. Coronavirus, not so fun, not a game. So here's an article by Tomas Puello from March 10th, Coronavirus, Why You Must Act Now. I'll try to send a link for this. Uh, so he has some interesting pictures here. Let's assume they're correct. Okay. Look at this. Coronavirus cases per country. South Korea, kind of a J. By the way, here's January 22nd over here. Here's March 7th over here. Look at this. South Korea, Italy, Iran, 3 countries very hard hit by coronavirus. Uh, kind of J curves there. Very frightening. We don't want J curves. We want to bend the curve, bend it down. We want to bend these curves down. And let's hope that in the United States, we won't have to deal with these kinds of J shapes. South Korea actually has done a lot to combat this. Italy even, at least it may have reached an inflection point where the number of new cases at least has declined. So maybe it has reached an inflection point and the curve will bend down a bit. So there is real application to what's going on nowadays. In the next video, we will start the notes on Chapter 3 on exponential growth.